I'll record. See here, what you will do is, there is a numerical A cross B, A cross B. That is in cross product. Yeah, the cross product, or vector product. Okay, cross product or vector product. Clear? This is A cross B. In A cross B, how do we do the numerical? How do we do that? A is equal to ijk, something will be given. I cap plus j cap plus k cap, some vector will be given to you. And B bar also, they will give some vector. What is that? Maybe 2i plus 3j plus 4k. Some vector is there. So what you have to calculate, like R is the one vector, F is one vector. F cross R. Okay. So what you will do now? Now is equal to, suppose same thing, A cross
A
B you will
cross B.
calculate.
Yeah.
For A cross B, how do we do that? You take I cap, j cap, and k cap, and you write those values 1, 1, 1, and 2, 3, 1, something like this. Okay. And you will find out the vector, I cap into 1, 1, 3, 1 minus j cap into 1, 2, 1, 1 plus k cap into 1, 1, 2, 3. Is it clear? So I cap into 1 minus 3 minus j cap into 1 minus 2 plus k cap into 3 minus okay. So it will become 2i cap minus plus j cap plus k cap. Like this, you'll get a resultant vector. Got it? The same way, you will get two vectors. You need to solve that A cross B. Or that is tau. This is nothing but if this is R and this is R, then that is tau, torque. Understood? Is it clear?
Yes, sir.
Yeah, that is the way you will calculate. Okay. Now, not only that, if you go to the law of motion, yeah, or if you are going towards stretch and strain, okay, the cables and all that we will do. That is there in the next chapter that we will try. And you know, one more is there. We will go to gravitation now. Okay. In gravitation, that is variation of g with height, variation of g with depth, escape velocity, orbital velocity, all these derivations you must learn derivations, and you must also learn the numericals based on this. Derivations and numericals based on numerical on these four topics. Okay, is it clear? Is it clear, sir? No one is replying.
Sir, can you
Yes,
please
sir, yes,
just
sir.
repeat?
Yes, sir. Yes, sir.
See once again, these four variation of g with height, depth, and escape velocity, orbital velocity, all these four topics, these derivations you will learn, and you will also learn the numericals based on that. Okay,
Okay. Sir.
is that clear? So that is
So
important.
what is the gravitation of gravitation with the change in height, gravitation with the change in depth, and
I
what is the
didn't
third
get
one?
it. What is the gravitation?
Sir, GH, GD, understood. What is the third one?
Escape velocity, orbital velocity. VE, VO.
Okay, okay, that's V. Okay, okay, that's V. Okay.
VE and VO. Okay, that you learn. Okay. So you see not only this, how it depends. Example. So does the orbital velocity depends upon the mass of the planet? Or around which it is orbiting? Does it depend on that?
Yes, sir.
See,
Yes.
VE is equal to square root of 2GH.
2
And VO is equal to root GH. Okay, root GR or whatever H or R they have given. Now, does the escape velocity depend upon the mass of the planet, how it is proportional, if it depends. And the same way for orbital velocity, does it depend upon the mass of the planet on which it is revolving?
The escape velocity is inversely proportional to mass.
No, that you have to see dependence. The dependence I mean here, dependence you have to see. Is it dependent? Is the escape velocity dependent on the mass on the planet around which it is revolving, or around from which it is escaping? Does it depend upon the mass? Does it depend upon the radius of the planet? That you must see dependence. You got my point.
Yes, sir. It does depend.
Then how it depends? If it depends, is it square or is it root or is it 1 by something? How it is? That you must see.
Sir, here, yeah, escape velocity in our notes, it's like root 2.
But in the formula it is not there. If you are saying it is dependent, then in the formula it's not there.
So
You must see that. Okay, or it is independent of that. It may be independent also. You must see all these things.
If the mass is bigger, then the G will also change here.
Very good. The G will change. Definitely. Perfect. Yeah. So now you're getting the idea, right? You should know the dependence of the variables, how they are depending on each other. Clear?
Yes, sir.
Yeah. So, yeah, that is true. What is the escape velocity of the satellite on the Earth? Escape velocity, how much it is? Any idea?
So what value do we have?
Escape velocity for Earth, how much it is?
For Earth?
It is 11.2 kilometers per second. No, dear. Escape velocity for Earth is how much? 11.2 kilometer per second. And orbital velocity is 8 kilometers per second. Clear?
Yes, sir.
Yeah, 11 kilometer per second.
Please you do this numericals also, man, and also learn on numericals on this height and depth also. This is very, very important. Okay, learn this. That is very, very important.
Okay, sir.
When I say in this case here, when I come to the motion in a plane, man, for a second I'm just going back in motion in a plane. Okay, here when I say maximum range, what is the angle? When I say maximum range, what is the
45.
angle? Huh?
80.
45.
Exactly. Very good. Yeah, when I say maximum range, angle will not be given there. Maximum range means theta is 45 degrees. Is it clear? Learn this one. This is important. You have to apply this in the numerical. Clear?
Okay, sir.
Now suppose the numerical will be like, it won't be a direct numerical, especially for all these four. There won't be a direct numerical. Example, like what happens to the at what height? Okay, at what height the gravity will become GH? The gravity will become 30% or 50% or 25%, which is there on the earth, surface of the earth. You got my point? What is the gravity? What is the height at which the gravity will become 50%? Or what is the height at which the gravity will become 25% or 30%? How will you do that?
Can you show a question like that, sir?
And that's what I'm asking. You must have an idea of that. Suppose my formula is GH is equal to G into 1 minus 2H by R. No. Suppose he says that what is the height at which the gravity value is how much? 50% means 0.5. 50% the gravity on the earth. Is that clear? On the surface of the earth. Is it clear, sir?
Yes.
So in that case, what will happen? GH will be 0.5 into G or G by 2. Okay, G by 2 into G into 1 minus 2H by R. G and G will go away. 1 by 2 is equal to 1 minus 2H by R. Implies 2H by R is equal to how much? 1 plus 1 by 2. 2H bar is equal to 1 plus. So 2H by R is equal to 3 by 2.
R equal to
Implies H is equal to
3 by 2
3R by 4.
by
Got it?
4.
Means
Yes.
when you travel a distance, the height is how much? The height is 3R by 4, 75% the radius of the earth. Then only the radius, the gravity is much. Like that, you can apply for 25% also, 30% also. Got it? The same like what happens to the depth also.
Same value but in negative.
Like suppose here, example, what will be the, suppose there is a like 50 kilometers below the earth. Example, the depth is 50 kilometers, means 50 into 10 to the power of 3 meters. What is the, not only the GD, you need to sometimes you need to find out what is the weight at that point when you go deep in the earth. So GD is equal to G into 1 minus D by R. No. So GD is equal to how much? G into 1 minus D by R. 1 minus D is how much? 50 into 10 to the power of 3 by R. Okay. Now once you calculate this value, once you get this value, then what is W? W is equal to mg, no? W at D is equal to m into GD. So at that point, what will be the mass? Suppose if the mass is m. Okay. If the mass is m, what will be the, here you will be given the radius of the earth. What is the radius of the earth? How much it is? 6,400 kilometers. This is a standard value. Okay, if it is kilometer, then no need to again write 10 to the power of 3. Suppose if it is 6,000, suppose they have given like this 50 kilometers. GD is equal to G into 1 minus D by R. 1 minus D is how much? 50 kilometers by R is 6,400 kilometers. Okay. Now when you solve it, you will get GD value. Okay. Once you get the GD value, then substitute in weight. Weight is equal to mg, no? M into GD. Then you will get the answer for the weight at that place. You understood the problem?
Yes, sir.
Derivations are there. That is a different thing. Derivations, they will come in the exam definitely. That's okay. No, but the numericals also you must learn to get full marks. Is that clear?
Yes.
Hmm. Okay. So okay. So this was about gravitation lesson. Anything else to be discussed here? And also same like for height also. So what is the value of G when it is at height is 500 or maybe 200 kilometers from the earth? How much it is? Just substitute. GH is equal to, so GH is equal to
1
G
minus
into
4
1
into 1
minus
minus 4.
2H by R, right? G into 1 minus 2H by R. Substitute in this formula, you'll get the answer. Okay. Now, what is the next chapter after gravitation? Rotational motion, right? System of particles and rotational motion. Yeah.
Yeah.
System of particles and rotational motion. One second. Give me 1 second. Yeah, system of particles and rotational motion. So what ma'am has given here? Hmm? What are the important questions? What are the topics to be discussed? Center of mass? Yeah. You must discuss center of mass.
Everything is coming from rotational motion.
You must learn. That's what I'm saying. You must learn center of mass. Okay. So center of mass numerical, what is there? Center of mass numerical.
That's like M1 dash one, yeah. M1 and
No, 1 second, 1 second. We'll discuss center of mass numerical. Wait.
moment of inertia is coming. Rotational inertia. Sir, center of mass is the equation. One equation is there, yeah. Formula
I'm not getting what you're saying. Little louder.
So there is one equation, formula for center of mass, yeah.
Suppose, yeah, there is
R
a mass.
vector
No, the
CM.
formula, what is it?
R vector of center
M1,
of mass is equal to
M1
M1
x1
R1
plus
plus
M2 x2
M2
divided by
R2
M1 plus M2.
M1
Same way,
plus
comma,
M2. But everything in vector.
M1 by 1 plus M2 by 2 divided by M1 plus M2. Now, suppose here M1 is equal to 2 kg and M2 is equal to 3 kg. Example. And the coordinates are given to you like this 1 comma 2. And this is 3 comma 5 comma 4 comma 5, something like that. Can you substitute in this formula and tell me the answer? Quick, only just substitution is there.
Yeah.
You'll get the answer in terms of the coordinate. It's a simple calculation. Find out, come on, quick. Don't take tension, man. Everything will come. Okay, whatever I'm discussing. Okay.
Fourteen by 5, 19 by 5.
Very good. Something like that. Okay, you'll get a point. 14 by 5, 19 by 5. Something like that. Okay. So solve this type of questions. Now, what else is there to be discussed? Yeah, in rotational motion, man, see here. Like you will be given like angular acceleration. Alpha is equal to maybe 3 radians per second square. And time t is equal to 3 seconds. Okay. And
One doubt.
yeah,
So there is velocity of center of mass and acceleration of center of mass. So both are there, yeah, coming.
velocity of no, that is not needed. No need.
No,
Just only the center of mass. That's enough.
only center of
That
mass.
is enough. Now, can you calculate if omega I is equal to 0? Can you calculate this? Which formula will you use here? Out of 3 formulas. Omega F V is equal to U plus AT, alpha T. I think this fits. Yeah. Try now.
Yeah, alpha T. Yeah. The first
Do
Yes.
it. Yeah, do it.
Nine.
9. Yeah.
Yeah.
Omega is 0. Yeah, 3 is 9. Direct question. 9, what is that? 9 radians per second.
It's per second.
9 radians per second. Hmm. So how will you compare force and torque? Comparison. You know the analogy, analog, rotational analog, and there are some, when there was a tabular column, there's a tabular column in the book, like all the no linear equations, then angular. F is equal
The
to
law of
ma.
conservation of angular momentum.
No, like F is equal to analogs are there. No, if F is equal to ma, in rotational motion tau is equal to I alpha. Rotational
Yeah.
analog of mass is I. Okay, I alpha, like that. And if it is P is equal to mv, then angular momentum is what? I into omega.
I into omega.
Yeah, like that. Is it clear? You have this for analog, right? The rotation analog, linear and angular, that you must learn. Now, we will go to the disk, disk sphere. You remember that? Hmm? There is a tabular column in which you have values from and the formulas are there. Remember.
No, sir.
One tabular column is there, disk is there, ring is there, a rod is there. Remember? In
The rate
in
of change of
in one
momentum
of
is
the
R into F, yeah.
no man. When you go to rotational motion chapter, in that there is a one big table in which what is the moment of inertia for so and so. Remember that? Learn the relations. Go to the relations now. What is the relation between I here already wrote here. What is that? Tau is equal to I alpha and L is equal to I omega. There are some more definitions. No? What is that? What are the names? This is part 2 I have. No. Any other relations? Just turn the pages of the textbook.
Sir, can you please complete like before 6:20 so that we can go for prayer? I'll check this out later.
Yeah. Okay. Otherwise, I will take tomorrow also. Don't worry. Don't take
Okay.
stress. Okay. How much we will be
Okay.
able to do today, we will do it, and tomorrow we will continue. Okay. Don't take stress.
Okay.
Yeah. The spinning. Suppose there is a angular moment. Initial angular momentum is given to you, and torque is given to you. Time is given to you. What will be the final angular momentum? Any idea? Like suppose initial angular momentum is given to you. Final angular momentum you need to calculate. Torque is given to you. Time is given to you. Now, suppose if this is think that this is 4 or 3 kg meter square per second. Okay. And here torque is equal to, let it be 4 Newton meter. Time t is 5 seconds. Can you try this question? What will be the final angular momentum? First of all, what will be the formula to be applied here? Any idea?
So is there any delta L formula?
Think, just turn the pages of your textbook. Angular momentum part topic. Tomorrow also have exam tomorrow. So I'll try to take in the morning there from there. Okay, from the school. Clear?
Okay. Okay, sir.
In between, if I get free, I will try to take the class from there.
Morning when?
Around, see, my examination timing, I will tell you. Exam starts 8:45 to 12 o'clock. Okay, so I'll be free in between. You can approximately from 9:15 to 11:30 around, I will be free. And during that time, if you want, I will be there with the, okay, I'll explain this.
So tomorrow, can you concentrate on the last lessons, like the
Second,
ones
yeah,
in
we
the
will do it on
last?
the second book. Don't worry. The second book, and we will also discuss the chapter wise what is the weightage. Okay.
Okay.
Okay, sir.
What is the weightage? Chapter wise also we will discuss. Don't worry. Why are you taking tension? What will be the answer for this? Go to Google and type the relation between L, tau, and T.
So what is that? 4 Newton meter. Which one? L.
This is initial angular momentum. Final angular
Okay.
momentum you need to calculate. What is the torque is given to you? Time is given to you. How will you calculate the?
This one. Yeah. What do you say? Relation.
Huh?
This one relation for this. Yeah. To calculate this.
No, I'm not getting you. It's very voice is very low.
This one. Relation for the.
What is that? Go to
Relation, yeah,
Google or
first.
go to textbook. If you have textbook, open the textbook. You'll find the relation. Then substitute in that relation. You'll get the answer.
Tau is equal to dl by dt.
Tau is equal to dl by dt. Very good. Now, yeah. Tau is equal to L2 minus
dl by
L1
dt.
by delta T. You can take. Tau is equal to 4 is equal to L2 3 minus L1. Sorry. L2 minus 3 divided by T. 5. 5 fourths 20. Then L2 is equal to how much? 23. 23 kg meter square per second. Understood now? Use this formula to solve it. Okay. So for time being, we will stop here for today. Okay. So the first book we have done. Okay, today. Tomorrow we will start with the second book. Okay.
Okay, sir.
Is it clear? Other than what ma'am has given, I have discussed with you. You can go through. Anyways, I'll post the link in the group. You can once again you can see. Okay.
Okay, sir.
Thank you.
Okay.
Thank you.
Thank you, sir.
Yeah.